Hey, how's it going, everybody? Um, I have the pleasure of presenting the hardest concept in geometry to you today. We're going to talk about geometric proofs. The reason why these are introduced so early is because we're going to spend pretty much every section working on them. You'll be doing proofs from now until basically the end of the year. I wish to say that there was some super easy way to do them, but I mean, there's not. So I'm going to do my best to make this as painless as possible. I've already made the quiz, so this is kind of like a weird, I'm doing it differently. Instead of doing this and making the quiz based off of it, I'm going to teach you based on the quiz that you're about to take. I think it'll help a little bit. At least here's hoping. So I'm setting up a statement and reason chart here. Now, we've done algebraic proofs. They weren't difficult, not by any huge means. And, you know, theoretically, this shouldn't be difficult. But the hardest part about geometric proofs is that every single topic we've ever talked about, every basic vocabulary word we've ever seen, can be a reason in the proof, can justify an action or a movement in a proof. So we're looking at this picture right here. We are given a couple things. We're given that angle BAD, sorry, angle BAD equals 6x plus 4. I haven't done this proof yet, so you get to actually see me reason through it. We're also given that CAD equals 4x plus 6. And we're actually given one other thing, which was BAC is a right angle. All right. And what are we trying to prove? Well, what we're going to be trying to prove is x equals 8. All right. Right, x equals 8, 10, 10 equals 90. Yeah, cool. All right. So it would be real nice. It'd be real nice if we could just do the math here and figure it out, right? But that's not how proofs work. So we're trying to prove that x equals 8. Well, anytime you're given a variable in geometry, you need to find an equal sign between the information you were given. We have this angle equals this angle equals this, and then that we've got a right angle right here. So we need to figure out an equal sign. These two have some kind of relation where we can put an equal sign in and start solving. Now, I don't know if you remember this, but angle addition postulate is when you have two angles side by side, just like a segment addition postulate, they add up to the entire angle. We know the entire angle is right here. It's a right angle, 90 degrees. So we know that this plus this will equal the whole thing, which is 90. Once we get there, we can solve. So let's get there in the proof, because there's a lot of steps. The very first thing you should always do is write out your givens. We know that BAD equals 6x plus 4. And we know that because it was given to us, literally right there next to the word given. Nothing else in the proof will have a reason of given unless it was literally given to you. I have a pet peeve of people writing the words given and proof, proved or proven for the reasons. Yeah, don't do that. If it wasn't right next to the word given, then you weren't given it. Sometimes you could make an argument that information in the picture is given to you, but your test makers try not to overcomplicate things, and even if it's in the picture, they'll probably put it up here. All right. Okay, so we've got 3 givens. There's quite a bit of information that they've kind of thrown our way. And we got to prove x equals 8. Well, what we can do is, and what I suggest is, you look at all your givens and you see if there is anything you can do with them individually. So before I look at, all right, well, angle BAD is this, and it's here, and all right, too much. Angle BAD equals 6x plus 4. Is there anything I can do with this equation? And given the variable and that it equals something I don't know, like there's nothing I can do. Same with CAD equals 4x plus 6. But coming down here, BAC is a right angle. We can do something with that. We know what a right angle is, don't we? Right angle is 90 degrees. So I could say BAC equals 90 degrees, right? But how do I know that information? Well, anytime, this is another little trick or hint to proofs, anytime you see a vocabulary word in the statements, right, or a right angle, right, or supplementary, complementary, you see a vocab word where there should be math, then one of the reasons is going to be definition of that vocabulary word, because you're going to use that vocabulary word to create the math. If it was supplementary, you would have 2 things added together equal 180. Reason, definition of supplementary. We said BAC equals 90 degrees because that's the definition of a right angle. This is where proofs become very difficult. Every vocab word we have ever gone over, every basically geometry term I have said is now fair game to be used in a proof. Now, you will never have to do a proof from scratch like I'm doing right here. And you'll see on the quiz that it is significantly easier than what I'm doing right now. But I like to show you the hardest it could possibly be so that, you know, when you have to do it, it's nowhere near this difficult. But we're going to move on. So now we've worked with all 3 of our givens. We've gotten them to basically a point where we can't do anything else with them. So now we need to go to the picture and start looking at what we can do and how we can kind of slap these together. So I gave you that big hint at the very beginning, and I said, well, you know, this angle, we'll mark it with the arc. It can be black, it's fine. This angle and this angle are right next to each other and are both inside BAC. There are 2 angles inside this big angle. So they could add up to the whole thing, right? Pieces add up to the whole. So I know that this plus this equals the whole thing. And I can write that out. Now, I can't jump straight to the math, but I can say, based on the picture, that angle BAD plus angle DAC will equal the whole thing BAC. I know that this plus this piece plus this piece will equal the whole thing. And that is angle addition postulate. I know we studied that a long time ago, but geometry is cumulative, as in everything we learn is fair game on the next concept. So I know you've heard this a lot about other classes of, you know, oh, well, if you don't know this or you don't remember this, you're going to be in trouble. And then you study for, you know, everything the teacher gives you for a week, and then you ace the test, and it had nothing to do with anything else you learned. This is the turning point where geometry goes, hey, everything you learned is actually important. This is normally where a lot of people have trouble with the class. But again, I'm going to try to make it as easy as possible. So we've got BAD plus DAC equals BAC. Now, oh, I should change that. DAC is the exact same thing as CAD, right? They're exactly the same, it's just different order. I'm going from C to A to D or DAC. I just realized that I was going to confuse some kids if I didn't flip that. Okay, back on here. We actually know values for all of these, don't we? We have BAD is equal to this, 6x plus 4. CAD equals this equation, and BAC equals 90. Well, anytime two things are equal, they can be used in each other's place. They can be substituted. So I'm going to create my equation now. BAD is going to be turned into or substituted. It's going to become 6x plus 4. Because these two things, BAD and 6x plus 4, are equal here, I can make any instance of BAD become 6x plus 4. And I could go the other way too. If there was a 6x plus 4 somewhere, I could make it BAD. So we did that with BAD, and it's going to get plus because it was BAD plus, and this is now BAD. And then CAD is also an equation. So we're going to make CAD an equation, 4x plus 6. So BAD, this guy, plus CAD, this guy, equals, and then this angle, BAC, the whole thing, we have an equal sign as well. It's 90. All of that is substitution. You don't have to do, substitution property. I'm just going to put substitution because you don't have to keep writing the word property. So here's the tricky part, though. There is no showing your work in a proof. You just go to the next statement. So when we combine like terms over here, we're going to get 10x plus 10 equals 90. But that is not what you write down. Because all you did was simplify. All you did was take this equation and combine like terms. That is not a step. But if you were looking at 10x plus 10 equals 90, how would you start getting x by itself? Well, this 10 is attached through multiplication, so that's going to have to wait. It's too close. But this plus 10 right here, I would subtract that from both sides, right? Minus 10 from both sides. That's what you're going to write down. 10x equals 80. So we combine like terms, but what did we do to both sides? Well, we subtracted, and that's subtraction property. Not the right property. So we turned our angles into what they were equal to. We combined like terms and then moved something. There's our subtraction property. We minus 10 from both sides, have 10x equals 80. And then, well, if this is attached through multiplication, you always use the opposite. Opposite to move it to both sides, or to get it away from x. So when you divide both sides by 10, you're left with x equals 8. That is what we were trying to prove. This will always be, what you're trying to prove will always be the last statement in a proof. Always the last statement. Thing is, the reason can change drastically, because the reason is just how you got here. It has nothing to do with anything up here, but what you are trying to prove will always be the last statement. And how did we go from this line to this one? Well, we did it by division property. And that's it. You're done. You will never have to do a question like this in terms of, here's a picture, given, prove, fill it all out. At most, I think the hardest question I've ever seen students be given on a question or on proofs like this is there are multiple drop-down menus. So like, let's say this would be blank right here. Can I do something like that? Let me see. Yeah. So it would be something like this would be blank, and then like this would be blank. I think the most I've ever seen is 3 on the geometry FSA. So yeah, you would click here and it would be like 4 answer choices. Click here, 4 answer choices, click here, 4 answer choices. And you'd have to fill them all in. That's the hardest question I've ever seen. Most of the time, though, the questions you are given are more like, you know, you've got, oh, where'd the stuff go? Where did this? There it is. Most of the time, though, the questions that I have seen are, you know, hey, here's a whole proof. On line 1, 2, 3, 4, 5, on line 5, what's the statement that is missing? And then you just fill in this one statement. So despite proofs being the most difficult concept in geometry, they are not tested in a very difficult way. But it's still, you know, one of the hardest things you'll do in this class. So I'm always open for questions, comments, and concerns, of course. I'll erase this so you can see the whole proof there. I made the next quiz kind of short, but there's going to be a couple of rounds. We're going to go through this. We're going to practice this. This is definitely something that we need to do a couple times. But I'm always open. Message me if you need any help. We'll set up a Zoom, whatever the case may be. Until then, I hope you have a great day.